Hello, so we are back, and this time we have a beautiful laptop to repair. Huh? Razer. Now, what's the problem with this one? Apart from the fact is that we have a customer letter. The main issue, the laptop is not turning on. It switched off by itself. I was using it. The customer sent the laptop to Razer. Razer seems to have failed to fix, and they are charging him too much to fix it. The main issue doesn't turn on. Main issue, please fix this one. Doesn't charge anymore. This is the secondary issue. Okay. The problem is on the customer email is saying the story is a little bit different. So the customer is saying it doesn't turn on, and last time it did, I smelled smoke smell. Also doesn't charge the battery. So here in the email, the customer is saying actually he felt some smoke from this laptop. Now the Razer, it's well known about a poor motherboard, and usually, it's ending up with burn layers on the motherboard. But let's open this one and have a look. I always take a new job like a challenge, and it's like, make you feel good when you can solve the riddle. Okay, so the laptop, it's open. That's a nice motherboard and heatsink. I mean, check here how much copper it is. Like, even the chipset has a heatsink. Huh? Okay, let's unplug the battery. And what do I want to check first is the main power rail, but I can't see anything. We have a fuse there. Let me take the heatsink out. Okay, so the heatsink, it's out. Everything is looking fine here. So let's check the main power rail. Now here you have a bunch of MOSFETs everywhere, MOSFETs. So ground, we plus, and we have 5.5 ohms, which is very bad, 5.5 ohms. I'm assuming that's the CPU, 3.3 ohms, 3.3, 8.5. No, probably it's the VRAM. Probably is the VRAM. 23 ohms. 1 second. Could be the chipset. Chipset, 48 ohms. Interesting. Let me grab the thermal camera. I mean, from where can be this high resistance? 5.5 ohms? Yeah. Let me lower the voltage to like 0.9. Yeah. We need a ground. Yeah, this is a good ground. And plus on the capacitors, right? Here. And yeah, it's taking only 170 milliamps, you can see, because we have the resistance is high. CPU, GPU, just place your bet. What is that? What is that? That one. I can't really. This one is a MOSFET. Really? Let's have a look. Oh lol, so what is here? Because looks like thermal paste, but this black thingy and this, what is this white thingy? And here it's actually blow up or what? What is this solder ball? Those are DRMOS. I mean, this is giving me some hopes. Because can be only the DRMOS to be shorted. But what is that black thingy? This one. Oh, burn layers? Oh, that sucks then. That sucks. Oh, and they are everywhere, even on this one. Even on this one, check there. That sucks, proper sucks. I mean, all Razer I got are burn layers on the motherboard and proper burn. I mean, I could not fix them. Yeah, on this point is I don't know if it's any point trying to move forward. Just because the layers are burned exactly where are the DRMOS. And we have two different DRMOS, 1 second, with two different coils. And the coils are not together from what I can see. So compare with ground, this one 24 ohms and this one 24 ohms, and together 0 ohms. Okay, can be together. So that means we can get rid of one DRMOS if we cannot do it. But probably the DRMOS is good. Let's check the main power rail. Is still shorted? Yeah, like 12 ohms we have now. 12 ohms. So what we can do? What you will do in this case? You know, I'm curious your opinion. I mean, we don't know what is here because the layers are burned here. This corner is gone. Oh wait, this is burned here actually. What is this? We can make a hole on that DRMOS. Yeah, we can make a hole there. Okay, looks bad. Looks bad. I mean, you've seen, because I had before Razer, you see like a little dark spot here. Okay, just a little bit burn layer. But when you try to come with the current, you see like a big layer across the motherboard is getting hot. Yeah, I had a Razer with this kind of fault. I mean, I'm afraid we are losing time. That's what I'm afraid. This is metal frame, right? Yeah, it's metal frame. Okay, let's let the board there. Let's use some Kapton tape and let's try to take the MOSFETs out and have a look. Huh? Just trying to keep it short in case we cannot fix it. At least we didn't lose time. And let's use some Kapton tape over the VRAM. We need like a medium nozzle. (480°). Let's see. I can't take it out. Okay, this one is out. I can't take this out. It's welded. This one is welded to the track. And the burn layers are, check here, burn layers. Exactly on the plus track. Yeah. Let's see for short. So we took off the chip, the track is broken, and we don't have short. Lol. Oh, here is ground actually. Here is plus. And this plus is going where? Here. No, here. Yeah. But even here we have burn layers. Check that. You see burn layers? Yeah. So what we can do, what you will do on a case like this? Even here, check here, it's a beginning of burn layers. You see, this is the plus track. Here we are missing a pad. Okay, I want to hear some opinion. What you will do in this case? Just give back the job and that's all. Yeah, but I wanted to fix it. You know what I mean? The Razer, they could not fix it. I want to fix it. I want to be able to fix it. Yeah, here is fine. There's no issue here. Perfect. Here, we need a pad. Let's see what is this pad. Yeah, we can compare that pad. Yeah, 1 second. We can compare that pad with this one from here. So this one is mixing this one. And this one is ground. Let's see. It's no ground. Is plus. It's not plus. Okay, that sucks then. What that pad is doing? Where is going? It's not used. No, it is used. Check that is going somewhere. You can see it's going somewhere. Let me switch to diode mode. So this one, compare with ground. Yeah, we have reading. That means it's going somewhere. Feels bad. But 1 second. The last two pins. Yeah. Those are together, right? This one? No, it's not together. It's plus. So the last pin here is plus. And the chip we took out, the last pad is gone. Where is the ground? 1 second. This is the output. No, what? Wait, this is ground. What is this? Ground, ground, and the coil has 18 ohms. 18 ohms. Okay. So this one is ground, this one is ground, and this one 18 ohms, and that's plus. So ground, ground, no, ground, ground, and that's plus. It's not shorted. Plus with output is 133 ohms. You think it's good? 123 ohms. Where is the other chip? This one is good, but plus we output we have nothing. Okay, this looks good. Plus we output nothing. Ground we output nothing. So we are assuming this chip is dead. With output we have 190 ohms, but can be because of this thingy. A 190 ohms. No, I believe this is toasted. This one. Yeah, we can't use that one, but this one, this pin is used. but it's looking good. Yeah, no short. So what do you think about this one? Can we fix this chip? Can we fix a chip? Chip can be fixed? I'm not sure what is this track from here. Yeah, I found it. So the first pin is not connected. Pin number 1 is not connected. It's the one which is toasted. Pin number 2 is ground, and it is. Yeah, this one. So that pin is not connected. And this pin is actually ground. No, this one. Yeah, it's ground. Not sure what pin is this. This one is ground. This one is not connected. But this one looks fine. But here, this pin, I have 37 ohms. Okay, both chips are gone. But we should buy or not? The problem is, even if you are buying chips, yeah, we can buy one. That means we can make this laptop to work, but it will die soon because all the pressure, it will be on one MOSFET. We cannot feed two MOSFETs here. We don't have a power good pin, right? No. Okay, you know what? Let's try to power on the laptop. Yeah? I'm assuming this is the power supply. But again, I'm only assuming from the VRAM, yeah? 0 ohms, yeah. So this power supply is from the VRAM. Those are together, yeah. The VRAM is kind of a fixed voltage. Kind of. Okay, let's plug the charger. So plug in the charger. The charger is plugged. Pressing the power button. The laptop is coming on. That's crazy. It is coming on. You see, look, the fans are spinning. The CPU is getting hot. I mean, we can disable the GPU is getting hot also. We can disable the NVIDIA chip. And the customer can still use... You know what? I believe the VRAM is not shorted. Yeah, we have 18 ohms there. I believe it's not shorted. But I want to check a few things here. Let me grab the multimeter. Let me see first if we are getting any picture. Which the laptop should start on the Intel graphics, right? Wow, it's so hot. We don't have picture without the oh, we don't have screen, lol. Okay. Okay, we don't have screen. No one told me about the screen. Bad boys. You know what I'm thinking? I'm thinking to take the voltage for the VRAM from a different place. But that's what I want to check, if everything else is fine, and from where we can get that voltage. Someone said dodgy? No, you are on the right channel. No. Okay, let's try that one more time. We have picture. That's crazy. Actually, the laptop is working. Yeah, Intel graphics, yeah. But it's working. You know what I mean? Everything else is fine. Critical process died. I mean, not the laptop died. Just a critical process. Okay. I have a feeling I'm getting in something bad. Obviously, I'm not confident taking power from another power supply for the VRAM. Where can I find 1.2 volts? I can disable the GPU. That's what I can do. I can disable the GPU and the laptop will work on the Intel. But maybe we can get the voltage from somewhere. 1.2, I believe. Let's supply the voltage, but I can't play because I don't have heatsink. I want to supply voltage to the VRAM. And if we are supplying the voltage to the VRAM and the laptop is starting without error, then we are fine. You know what I mean? Okay, let's try with 1 volt first. Good. It's taking what? It's taking 140 milliamps. Decent. It's a decent amount of current, and it's coming on. It's taking 2 amps, 2.2 amps. Hopefully it's loading the windows right now, right? No, I don't want that. Loading the windows. 300 milliamps. Wow, the CPU is so hot. I'm not even sure if it's freezing because of the VRAM or because of the CPU not having a heatsink. So what we are doing? Okay, let's see what voltages do we have around here. We don't need screen for that. RAM memory. We can get the voltage from the RAM memory. That's crazy. Yeah, we can do it. We can do it. RAM memory should be a solid power supply, right? Where is it? Let me grab the multimeter. Yeah, RAM memory, 1.2 volts, right? Yeah, we can do it. So let's see. The laptop is on. Here we have 1 volt. Here we have 1.8. Here we have GPU. Here we have 0.9. What is the RAM power supply? Here. Ah, lol. They hide it. Found it. I found it. Let's see one more time. Here we have 3.3, right? Yeah. Here we have nothing. 5 volts. And here we have 1.2 volts. Check that. 1.2. We have 1.2 volts. Now, this VRAM is taking 3 amps at idle. You know what I mean? We need like a pretty thick wire. Now that coil, it will get mad hot. You know what I mean? The chip will get mad hot. What do we have? Dual MOSFET. Ah, that's fine. That can carry. That can do more. Yeah. Yeah, let's do it. Let me grab a wire. Yeah, we need something like that. Yeah, this seems to be about the right size to carry 1.2 volts at high amperage. Yeah, let me desolder the wire. Dodgy? What do you mean dodgy? When I'm doing something, it's dodgy. When the manufacturer is doing a BS, you know, that's okay. That's how it's supposed to be. That's not a problem. We can put some heatsink over that MOSFET and that coil. That's not an issue. The problem is we need like a short path. Yeah, we can have a short path. Don't tell me this is too... that sucks. No, it's not sucks. 1 second. But yeah, it is sucks. Yeah. Okay. The size of the wire screw up my dreams about this job. Indeed, the heatsink, you can see it's a little bit higher. But just a little bit. I mean, if we are using the wire, nah, it's too big. That proper sucks. We can comb like that. But we need a bigger wire. Yeah. Let me find a bigger wire. Found a, check here, speaker wire. Proper nice wire. Go, let's solder the wire. We're gonna solder the wire here on the test point, yeah? Actually, it's not a test point, it's a junction, right? You can disconnect that power rail. You know what, let me use some low melt solder. I will use some solder paste. 140-degree solder paste. Because it's a lot of wire here. Solder paste here. Good. We need more solder, right? Yeah. How is looking? A perfect solder wire, right? Yeah, here. So we have to route the cable. Yeah, it should be fine. It's solder. It should be fine. Okay, so we are coming with the wire like that. Yeah, like that. I believe we can come like that. And then like that. Fan and here. Yeah, we have to come with the wire here. What do you think it will work? It's a solid plan, right? Yeah, seems to be a solid plan. Kind of. It is a solid plan. Yeah, we need to go with the wire on that side. In order to carry a lot of current, we need to solder every wire. You know what I mean? Okay, let's leave it like that for the moment. Seems to be okay. Okay-ish. Ready for the final test? Huh? Ready, yeah? Good. Oh, we don't have thermal paste on the CPU. Yeah, actually we have. Yeah, we have thermal paste. It's even too much. GPU, yeah, we have. All good. Do you see what I see? Why we have thermal paste here? So the pad is missing and inside is thermal paste. Probably that's how everything started. Possible someone opened to replace thermal paste and this pad get ripped off. So someone put thermal paste here and I hope it will touch with the DRMOS. Yeah, possible. Possible. Okay, the heatsink is back in place. Good, let's plug the charger. And now is the moment. Now is the moment. Plug in the charger. Pressing the power button. And here it will be like a little Chernobyl, right? Actually, no. Actually, it's working, lol. So the RAM power supply, it's working. And it's loading the Windows. And I get an error. You know what? I don't believe this error is from the laptop. No, I don't believe it. Let me try with a different SSD. This is some Windows error. Must be. Must be. Our thingy is working how it's supposed to work, right? Let's see. Pressing the power button. Yeah, Windows automatic repair. That's okay. One more time. And it's loading the Windows. The RAM power supply. I mean, we can get a coffee on the RAM power supply. We can get tomorrow coffee. Not tomorrow, Sunday. It's working. I can't believe this is my old hard drive with Windows. Yeah. What did you say about my modification? Check here. Yeah, NVIDIA chip RTX 2070. Fine. Doing like a render test? Yeah, we can do it. Render test. But GPU clock is 450. It's not going up, huh? No, it's not going up the clock of the GPU. And we have artifacts. Yeah, we have artifacts from the VRAM. Check here the artifacts. That sucks. Yeah, but it's working. Yeah, it's working. It's working till the moment you put some pressure on the VRAM, and the system is not freezing. It's freezing the GPU. Blue screen. No, it's not doing blue screen. No. It's only the NVIDIA which is freezing the VRAM. The artifacts are from the VRAM. Of course, you know what are the odds to match the voltage? Yeah, that's one thing. But you know, I'm surprising it's working. You know what I mean? Okay. You know, I had fun, but yeah. I mean, what are the odds? The VRAM voltage should be the same with the RAM voltage. Probably never it will happen. Not sure if this is like floating VRAM voltage based on a clock. It's not really important because we max out the voltage, the VRAM voltage, which is about 1.2. But when I'm saying which is about 1.2, that voltage is fine tuned. You know what I mean? I mean, you can't really use like any voltage. That's tuned based on the, you know, not the performance. And actually, you know, the VRAM in order to work and not take too much power. So it's like a thin line there. We could be lucky to be the same voltage. But on the other hand, my wire is getting mad hot. My wire, just to understand what kind of current is there. The RAM coil, I can't touch it. The RAM coil, I can't touch it. No. The RAM coil is mad hot. Lol, you know, the MOSFET, the VRAM MOSFET. I can't even touch it. That's probably, this is like 90 degrees. But the thing is, it's working. I mean, we done this kind of dodgy things on the past. You remember we took the... No, we didn't. No, not this kind of dodgy things. No. But we did replace like a power supply with a generic switching power supply. Well, I tried to help the customer, but didn't work. Yeah, still doing updates. So what is the solution? The solution is clearly I can't fix it like genuine, like how it was. Everything is burned there. Even if I fix it, there is no way I can give warranty for that kind of repair. I will disable the NVIDIA. I will take my wire out. I will disable the NVIDIA chip, and the customer still can use it on Intel. I have no choice. I have no options. Other option. No, I can't do it. No, everything is burned there. So even if I use like I ordered two other chips and use wires there. That's a dodgy job because we have burn layers there. Not only is dodgy, but that chip is getting cooled mainly from the motherboard and secondly through the heatsink. No, I can't do it. No, I can't go there. No, it's too risky. Okay, I will stop here. I will give the customer some option. To disable the VRAM and the NVIDIA, we did videos before, so you can have a look there if you want to see how it has to be done. But it was a nice try. Surprising, the VRAM is still good. Yeah. And the GPU is still good. I mean, all Razer, they have same issue with the motherboard layers. Well, I can't believe this was a long video. It's like check here, yeah. Check on the check here. On OBS, I have like 1 hour and a half. Well, it was fun, you know. I love doing these kind of things. You know what? For some reason, I believe. Listen, I believe actually this modification probably it will work. I mean, if you have higher voltage on the VRAM, it will work fine, no issue. It will get a little bit more current, but it will work fine. The issue is when you have lower voltage, then you'll have artifacts. And I believe on this wire, even this like big wire, we are still losing a lot of voltage. That's what I believe. I can't check, but I believe we are losing current. We are losing current, the voltage get dropped on this wire. This is a long wire. You know what I mean? That's the reason why, you know, you have the coil and you have MOSFET, CPU, GPU next to it. Because you are losing current, lot of current. I mean, this was taking like what, like 3 amps doing nothing. When you clock the VRAM, it's going probably over 10 amps. Only the VRAM. Now the RAM power supply is like a sitting duck. You know, it's just a disaster waiting to happen. I mean, with this kind of sick current, And I can see the way how they are getting hot. Probably it's just a matter of time till it will die. I mean, if it worked, yeah, if it worked fine, then we could use a thermal pass to suck the heat from there. But it's not, because this wire is too long. I cannot carry that much current. I mean, in order to carry current, like low voltage, high current, you need proper short tracks or proper big wires, like, solid copper. Yeah, I'm sorry. I tried to help the customer. Especially, I'm surprised to see the GPU is still good, the VRAM is still good. Yeah. Anyway, thank you for watching. Hopefully you enjoyed the video. Just like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.